Alright, in this video I'm going to look at an example of solving a system by elimination. Now, normally our steps for solving a system by elimination are to multiply by any constant that will make the variables cancel when added together. And then our second step is to add the rows together, add the equations together. So in this case, in example 1 here, I'm given two equations. The first equation is 2x squared minus 5x minus y equals negative 2. And the second equation is negative x squared plus 2x plus y equals 0. Now, in this example, it's pretty easy to see that if I add these two equations together, that the y's will end up canceling out, right? This negative y plus a positive y will end up going away. So I can actually skip step 1 here. I don't need to multiply by anything to get anything to cancel. It actually is lined up nice for me. So in this case, I can just simply add the two equations together and go ahead and solve from there. So when adding two polynomial equations together, we need to make sure we add like terms together. What I mean by this is the x squared terms need to be added to the x squared terms, the x's need to be added to the x terms, the y's to the y's, the constant to the constants. Now once again, this problem is pretty nice. It's all lined up for us. We don't need to do any rearranging. So in this case, we can actually just add down the columns. So for instance, if I take 2x squared plus a negative x squared, I'll be left with just 1x squared. If I take negative 5x plus 2x, I'll be left with a negative 3x. And if I take negative y plus y, well, the whole point of elimination was for those two to cancel, so we see that they do. And then if I take negative 2 plus 0, well, that's just going to equal negative 2. And then once I'm to this point, I'm down to one equation and one unknown. Now I want to solve this, so I want to get everything onto one side, so I'll add 2 to both sides. It'll give me x squared minus 3x plus 2 equals 0. And then once again, you can see here that I have a quadratic equation and it's in standard form. So anytime we have an equation in standard form, we want to factor it. So I can factor this equation into two binomials. And remember, we're kind of undoing FOIL on this step, so what times what will give me the first term? Well, that's simply just x times x. And then what times what, it's going to multiply to 2 and add to negative 3. Well, there's really only two numbers that multiply to 2, and that's 1 times 2. So if I plug in 1 times 2, I need them both to add to negative 3. So in this case, they're both going to have to be negative, and then that's equal to 0. Once I have the problem factored, and I have two parentheses being multiplied together and it equals 0, as long as it equals 0, I can now go ahead and separate these into two separate equations. So I can get this as x minus 1 equals 0, or x minus 2 equals 0. And then just simply solve each of these equations. Well, I can just look at the left-hand side one and see that the answer is going to be 1. And then I can look at the right-hand side and see that the answer is going to be 2. Now, one thing to note again is that anytime we solve a system, the solution to a system will always be a point. And if you notice right now, I just have an x value. So I need to have an x and a y value. What that means is I need to find the y values associated with each of these x values. And to do that means that I just have to plug my x value back into one of these equations. It doesn't really matter which one I pick. So I think for the first one, I'm going to pick this second equation, and like I said, I need to plug the x value into it. So to find the y value on the left-hand side, I'm going to take negative 1 squared plus 2 times 1 plus y equals 0. And then I just simply want to solve this for the y. Well, 1 squared is just 1, but there's a negative out front, so I'm going to get a negative 1. 2 times 1 is really just 2, and then that's plus y, and it equals 0. Here I can take negative 1 plus 2 gives me 1 plus y equals 0, and then solving for y, I'll get y equals negative 1. So in this case, when I plug an x value of 1 in, I get a negative 1 out, and my solution as a point will be 1, negative 1. Now to find my second solution here, I have x is 2. I'm going to do the same thing where I plug x into this second equation, but this time I'm going to make sure that I plug a 2 in instead of a 1 because the x value here is a 2. So I'm going to do this off to the side over here, and in this case I'm going to get negative 2 squared plus 2 times 2 plus y equals 0. And let's just simply once again solve this for the y. Well, 2 squared is 4, but there's a negative out front, so I get negative 4. 2 times 2, well, that's just 4 plus y equals 0. Notice that these two will cancel. Negative 4 plus 4 will go away, and I'll be left with y equals 0. So when x is 2, my y value is 0, which means my solution as a point is going to be 2 comma 0. So just some things to remember here. Anytime you solve a solution or solve a system, your solution is going to be an xy point. And anytime we're using elimination, our goal is to be able to add the two rows together to get one of the variables to cancel.